Guys, we have officially finished chapter 1. Finished and took the chapter 1 test. Your test grade is already in WinGauge, so they have been posted. We're on week, 6 or 5. I think I'm counting it as 5 because I don't think I counted the first 2-day week. Normally I do, but since we were still figuring out schedules and everything else, I didn't officially. Yeah. Now, the nice thing with this here is, unlike chapter 1, the rest of the chapters are going to pick a theme and continue on with that theme. So chapter 2, and actually chapter 3, is going to be quadratic functions. So what we're talking about in chapter 2 and chapter 3 is going to be quadratic functions. Now, you've seen quadratic functions before, because we talked about them a little bit in chapter 1. We're talking about x squared. F of x equals x squared. These are the types of functions we're going to be looking at. Now, one of the general forms is this here. A parentheses x minus h squared plus k. This is a general form of a quadratic function. Now, we do have 3 constants. A constant is a number. A constant term is a number. A, h, and k. Well, as we saw in the last chapter, A is our vertical stretch or shrink, and it's also our reflection across what axis? The x-axis. And this is all related to A. Because if there's a number for A other than 1, it's a stretch or shrink. If that value is negative, then it's a reflection across the x-axis. H is our horizontal translation. This is our left or right. And lastly, K is our vertical translation, which is our up or down. Now, last chapter, because we did talk about this, determining the transformations. And if you notice, after we talked about the transformations, being able to just look at them and tell, did they move left, right, up, down, stretch, shrink? The number of functions we actually looked at decreased by 1, because when we actually applied the transformations, we only talked about absolute values and linear. We didn't talk about quadratics. And that's because they decided to save those for chapter 2. We decided to put them all together. But when we apply the transformations like we did already, how we apply them still holds true. So what we did on the last chapter test, those transformations still holds true. So we talk about horizontal translation and a vertical translation. It's the exact same, and you do have those in your note sheet. Because a horizontal translation shifts left when h is less than 0, and it shifts right when h is greater than 0. Now, again, this is talking about the value. All right. So, horizontal translations, left and right. So it says it shifts left when h is less than 0, and shifts to right when h is greater than 0. But again, this is talking purely about the value of h, not so much the sign with it. Because if we said that we had x minus 4. Well, the general form is x minus h. The x is the same, the minus is the same, which really means that the value of h is positive 4. So it would move right 4. However, if we had x plus 4, well, the general form of this is x minus h. So really what this is saying is that we have x minus negative 4. So the value of h in this case is indeed negative 4, less than 0, left. But the way that we can kind of look at it to make it a little bit easier on us is it's kind of the opposite of what we think. If it's minus inside the parentheses, we're moving to the right. If it's positive inside the parentheses, we're moving to the left. Inside parentheses is opposite of what we think. Now with vertical, up, down, that's exactly what we think it is, exactly as we see it. If we have plus 4, we're moving up 4. If it's minus 4, we're moving down 4. And we've done these before. So when we look at these here, describe the transformation of f of x equals x squared to our function g of x equals x plus 4 squared minus 1. Now we're not going to graph it. We're not going to go through the process of graphing them. The most important thing is describing the transformation, and there's two of them. Because we have the negative 1 outside and we have the plus 4 inside. So the negative 1 outside, the parentheses, is moving us in what direction? Because outside parentheses is our up or down. So this would be indeed down 1. Inside parentheses, when we add or subtract, is our left or right. Now, would this be to the left or to the right? Left, how far? Left, 4. Down 1 and left, 4. So what that's saying, and I'm going to show you this here graphically so you can at least see it and think of this here. Because when we talk about this transformation, this here already given to you, it's on your note sheet, I have it up here, is the graph of f of x equals x squared. Now, as we just said, this function was moved down 1 and left 4, which means every point on this graph is moved down 1 and left 4. So this point down here at the bottom, 0, 0, is going to move down 1 and left 1, 2, 3, 4. Or here, 1, 1 is going to move down 1 and left 4. Negative 1, negative 1 is moved down 1, left 4. And we can do this with the entire function. 2, 4, down 1, 1, 2, 3, 4. 1, 2, 3. And we get this here. And this here is our new graph. It gives us an idea of how the function should look. Because if I know, I have a general idea of how x squared looks, and I know how it's moved or how it's transformed, I can get an idea of how the new graph should look and what it should do. Questions on this here? We ready for the next one? Describe the transformation of g of x equals x minus 3 squared. Because our x minus 3, opposite of what we think, is going to be right 3. Yeah. None of them. And part of the reason I say that is because of the graphing calculator. Because what we could do, well, clear this one out. X squared, there's our quadratic, which we have to begin with our parent function. And we said the new one, or even the last one, which was x plus 4 squared minus 1. That's indeed what we got. Yes? Well, I didn't have to actually do anything to graph it. This tool graphs it for us. That's part of the reason why. I don't know if I've said it in here, I don't emphasize graphing a whole lot is because the amount of tools that we have to actually graph has increased significantly. Yes? I don't know the technical term for it, but I know for just to use an agricultural kind of standpoint, the scythe used for harvesting, I think, wheat, do we actually go through teaching how to use one of those anymore? No, because we have more technology and better technology than that to use. It's not a great illustration, but we have the technology and ability to graph these for us. So having a rudimentary, a full understanding of how it works and being able to do it by hand isn't necessary anymore because we have this here. So as long as we know how to read the graph and understand it, we're good. We don't need the full basics. Does that make sense? It's also the same reason why we don't need a full understanding of how an internal combustion engine works. We can still drive a car. So I don't see a whole lot of reason for you guys to be able to graph these as long as we understand the core concepts of what it's doing and what it should look like. Now the one we just did, we can have x minus 3 squared. And we said it moved right 3. So from the one in blue to the one in black, it indeed moved the entire function right 3. Yes? And we can see that. That's the point of this here, is getting an understanding of how the function moves, what it should look like. So if we look at this one here, we have two key transformations. We have one inside the parentheses and one outside. The minus 2 outside would indeed be down 2, because outside the parentheses, when we add or subtract something to it, is going to move just like we think it is. So minus 2 outside is indeed moving it down 2. The minus 2 inside the parentheses would be right 2, because it's going to be the opposite of what we think. And another way to illustrate that is because our origin 0, 0, because it's at 0 when x is 0, y is 0, yes? If I want to get the y value to be 0, I can't have plus, it has to be minus, because 2 minus 2 would indeed get us back to 0. But then we have down 2, so it's just moving everything 2 to the right and then down 2. How about this one here? Up 1 and plus 1 on the outside is indeed moving it up. Exactly what we think. Inside the parentheses is opposite of what we think. So plus 5 is actually going to the left 5. Questions on any of this here? Pretty good with this so far. H of x equals x minus 1 plus 2. What's the x minus 1 tell us?
Oh, wait a minute. Never mind.
So right 1, yes. Up 2, yep. So inside the parentheses is opposite of what we think. And this is coming back to the fact that we have a parentheses x minus h squared plus k. Because x minus h, that's where we get that opposite, that minus h is where we're getting that opposite of what we think. Because the value of h in this case is not negative 1, it's actually positive 1. So we're moving to the right 1. Plus k is exactly how we get it, the same value, or exactly what we think it is. Plus 2, still just positive 2, so we move up 2. Questions on this here? And again, we can use these graphing utilities to make sure that's exactly what we have.
So this one is the opposite of the up and
exactly what we think it is.
Okay, I get it now.
Because I could plug it in and see, okay, it indeed moved right 1 and up 2. Yeah, it's just logging everything I've typed in since the last time I cleared it out. Questions on this here?
Does it matter if we write the up and down or the left and right first?
It does not. When we start talking about reflections and stretches and shrinks, it's going to most likely be better to do those last and the horizontal vertical shifts up, down, left, right first. Name them first, then stretch and shrink and reflections. Reflection across the x-axis. If we have a negative outside the parentheses, negative in front of the x, outside parentheses is across the x-axis. If the negative is in front of the x inside the parentheses, it's across the y-axis. Now they do show this here. This part, negative x squared is equal to just x squared. And that's purely because whenever we square something, square a number, multiply it by itself, it becomes positive. So if we just have negative x squared, well, negative x times negative x, negative times a negative is a positive, so we just get x squared. So when it's just negative x squared, it's just going to be x squared because it's reflected onto itself. If we have a translation left or right, negative x plus 1 squared is not the same as x plus 1 squared. Those are two different functions, okay? The only reason we can do that is because x was by itself. Now the same thing could be said if it was negative 2x squared. Negative 2x times negative 2x. A negative times a negative does give us a positive back, and we get 4x squared. But whenever we have that plus a number or minus a number, we have to take that into account. So, horizontal stretch and shrink, vertical stretch and shrink. Vertical stretch and shrink, we have that a value outside the parentheses. That a value is outside the parentheses. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink, because we've done these before. You all remember doing these, looking at the values of a. Now, the part of them that we didn't do is when we have a value of a inside the parentheses. I normally call this b so that we don't get them switched between the two, but it's the number in front of x inside the parentheses. When that value is between 0 and 1, it's a stretch. When it's greater than 1, it's a shrink. Now again, as we said with our horizontal translation left and right, it's the opposite of what we think, yes? Well, with vertical, if it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink, yes? Here, with horizontal, if it's greater than 1, it's a shrink, opposite of what we think. If the value is between 0 and 1, it's a stretch. And if you remember from last chapter, when we talked about horizontal stretch and shrink, we had to flip it, yes? We'll still do that when we talk about its transformation. So let's look at this here. Negative 1/2 x squared. So that a value does have a number, yes? We have the negative 1/2. Is it inside or outside parentheses? Outside. If there's no parentheses, it's automatically outside. So there's two things. We have the negative and we have the 1/2. The 1/2 would be a vertical shrink of 1/2. Because vertical stretch and shrink is not about the negative. It's not about the negative. It's about the number. Since the number is 1/2, it's a vertical shrink. If the value had been negative 2, it would have been a vertical stretch. If the number's between 0 and 1, did I throw my pen? It's a shrink. the sign means nothing for stretch or shrink, vertical stretch or shrink. The sign is not attached to vertical stretch or shrink. The sign is attached to what? Reflections. The negative. When A is negative, it's purely talking about a reflection. If it's outside the parentheses, it's across the X. If it's inside parentheses, it's across the Y. So the negative here is truly talking about a reflection. Yes. If it's inside parentheses, it's on the Y. If it's outside parentheses, it's on the X. So if we'd said 1/2 here, then we'd talk about a reflection across the y-axis. Outside parentheses is across the x. So the vertical shrink of 1/2 means that this is going to increase slower along the y-axis by a half. And a reflection across the x-axis means it's not going up, it's going down. So I could grab the calculator, clear this out. Negative alpha y equals enter 1/2 x squared graph. We can see it is going down. That's the reflection across the x-axis. And it's kind of a little hard to tell, but it is kind of noticeable that the one in red is wider, yes? It's increasing slower along the y-axis. That's our vertical shrink. Questions on this here? Let's look at another one. This time we do not have a reflection, because there's not a negative outside the parentheses in front of x or inside. But we do have 2 here. I would always address the up, down, left, right first. So the +1 outside the parentheses tells us what? Up 1. Now we do have a 2 inside parentheses, yes? So indeed, there is not a negative in front of this 2 here, so it's not a reflection across the y-axis or x, but it will be a horizontal stretch or shrink. Yes, inside the parentheses is still opposite of what we think, because times, or 2x, that 2 looks like it should be a stretch, yes? But it's not a stretch, it's a shrink. Horizontal shrink of 1/2. Well, you have to flip it. Horizontal shrink of 1/2. We only have to flip horizontal stretch and shrink. Stretch and shrink. Whatever number is inside the parentheses in front of that x, being multiplied by that x, we have to flip. We have to flip. And I will plug this in so we can see it here. Parentheses 2x squared. We can see that it moved it up 1, yes? Now, horizontal stretch and shrink. We're talking about the x-axis, moving along the x-axis. Now, we can see that the one in red is moving, increasing slower across the x-axis, yes? And that's what it means by horizontal shrink, is the movement, or as it's increasing along the x-axis, is slower. That's what it's getting at. Now, if I'm going to do 1/2 x squared, and we'll still leave the +1. Because now it's 1/2, so this would technically be a horizontal stretch. Opposite of what we think. And if you notice, the one in black is now increasing faster along the x-axis, yes? So if the value in the function in the parentheses in front of x is between 0 and 1, it's a stretch, a horizontal stretch. If it's greater than 1, it's a horizontal shrink. So we have to flip it. So again, as we said before, inside those parentheses is the opposite of what we think. It still holds true, because for this one here, it looks like a stretch, but it's actually a shrink. And the one I typed into the calculator, the 1/2 x, looked like it should be a shrink, but as we saw, it was actually a Let's look at the next one here. G of x equals negative 3x squared. So it is a, well, inside or outside parentheses, when we have a negative in front of that x squared, it is strictly talking about what? Reflection. Because when it's attached to that x squared, either in front of the parentheses or inside the parentheses, we're talking about a reflection. That negative is talking about a reflection. Now, the only place it differs is where it's across. Here, is it inside parentheses or outside? Outside. If there's no parentheses, it's automatically outside. So this is going to be across the x-axis. If it's inside the parentheses, it's across the y-axis. So we took care of the negative, yes? Now the next thing we have is the 3. This would be a vertical, what? That is the question. Would it be a stretch or shrink? The negative doesn't matter. We're talking about the number because the negative is only attached to the reflection. So the value of A is 3, yes? 3 with verticals exactly as we think it is, greater than 1, so it is a stretch. So it's a vertical stretch of what? Of 3. Yep. Questions on this here? Now I think we're starting to get a better hang of this, yes? Because we're not going to finish this today, obviously. We still have a lot more notes. But again, doing these here are going to be helpful for getting a picture of what the graph does. So when we start solving it, we can have a better understanding of what it should do, what it should look like, how these should work.